Hello, welcome back. This video is a bit tardy, as it were. This is the P-table lab from way back. I did this lab with the people that attended class, and I guess I thought I recorded it at the time, or I would record it at some point, while I was doing it with students, and just never did. I really feel like I remember recording this. But anyway, we're now getting toward the end of the semester, and there are people that haven't completed this yet. And because they can't attend class and et cetera, they need a video to help complete it. So that's what this is for. So if you are missing the P-table lab, I think it's from day 21. Yes, day 21. This is what this is for. I'm going to post this video in day 21's folder as well, so the people that run across it can find it. But anyway, here we go. So the first thing you're going to do is, of course, put in your name. And if you're doing this on paper, please write your name on your paper. And also, if you know what period you're in, I know that without ever being in school, you might not know, but okay. So you're supposed to go to ptable.com. I've already opened it up here, ptable.com. And what I want you to do at first, if you are doing this on your own and you're actually pulling up ptable.com and you're not having to do this on paper and just watch a downloaded video, please take a minute to scroll around and look at this website. It's got some amazing little bits of information and gives you all sorts of crazy views of things. And, you can, on this one, you can drag elements. Let's see, let's mix salt. NaCl. And now we made a compound. Oh, well, that's our compound. I'll have to play with this one a bit more myself. But anyway, so I want you to look around if you're able to. But if not, here we go. What color element symbol designates elements that are a gas at a given temperature? So if we go here and look, we've got a key where there's two keys up here. One key tells you what each of these little colors mean as far as the families. But the other key tells you that if the symbol is written in black, it's a solid at room temp or at that temperature, whatever temperature we've got right now. We have freezing for water, 0 Celsius, 32 Fahrenheit. It's written in blue if it's a liquid, and it's written in red if it's a gas. So hi. Apparently the meat is still open, but that's okay. So what we wanted to know is what element symbol is for gas. So that would be red. And if you write capital RED or lowercase RED, it should grade it correctly if you're doing this on the digital version. What family of elements does the orange color indicate? So we've got our orange color right here. And when we highlight it, that's our alkali metals. Family number 1 over here, alkali metals. So alkali metals. Then it says click on magnesium. What is its melting point? So we'll click on magnesium. And I want the information along the top. So what did we want about magnesium? We wanted the melting point. So up here on the top in the properties, the melting point, 650 degrees Celsius. You can also type out Celsius, but you do need to spell degrees correctly for it to grade it as correct when if you do it digitally. What is the symbol and atomic number of the element with the most protons according to this periodic table? So we know that the atomic number tells us the number of protons. And the largest number here isn't 103, because that's, you would think if we're reading from left to right, top to bottom, that 103. The problem is that 103 isn't the end. This whole row, the lanthanides and the actinides, all fit up here, actually. So that means that this one is the one with the highest atomic number. 118, oganesson. It says to click on its name, underlined in blue, to find out what year it was discovered. So we're going to click on oganesson, the underlined in blue name. And it was discovered in 2002. So, symbol OG, atomic number 118, year it was discovered 2002. Oops, not 1, 2. If an element symbol is written in blue, what information does it tell you? Okay, so we need to go back to our little key here. What does it mean when it's in blue? It's a liquid. Let's reduce the temperature to 0 K using the control shown in the upper right-hand side of the screen. How many gaseous elements exist? How many liquid elements exist? And then list the symbol of any elements that fall in these categories. So really, I just want you to look how many gases, how many liquids, and then tell me the symbol of any gases and liquids. That's what you're going to write here. So up here, we're going to type in 0. 0 Kelvin. And that takes us down to 0 degrees Kelvin. You see our temperature scale is way down here. It's the point at which particle motion ceases. And so that would mean everything's a solid, right? Right? I mean, I see, let's see if I put it on, okay. I see no reds, and they're all black except for that one, helium. Helium remains a liquid even at 0 degrees Kelvin. Wow. So helium does not have a solid state. And so the answer here would be helium because that's the only element that falls into that category. All right, now it says to change the temperature value to room temperature, which is 298 K, and then list any elements that are still liquid at room temperature. So, oh, wait, not 2980, just 298. All right, and there we were for half a second. It showed us we had bromine, francium, and mercury are the only ones that are still blue there. Do you see? Francium, mercury, bromine. Now we've got some gases at room temperature, of course. Oxygen, thank goodness. But we've got these 3 liquids at room temperature: bromine, mercury, and francium. So that's what's going to go here. Bromine, mercury, and francium. Notice how it says list the symbols. So if you type it out, you won't get the full point. It'll be 3/4 of a point. All right, for this one, you won't lose point. This is just an opinion. So what I want you to look at is the fact that these 2 rows go up in here. So if you click wide, it makes the periodic table look like the way it's supposed to. Those 2 rows are supposed to be right there in the lanthanides and actinides. Hold on. The reason why they did this is to make it so it would fit on a printed page. So you can imagine all, long like this and thin, it would maybe print well on a gum wrapper, and maybe you could print it on a big poster that's stretched wide, but you're going to have a hard time getting this to fit in a textbook or on a normal sheet of paper. So that's why the 2 rows are taken out and put underneath so that now it will fit neatly in a textbook, on a poster, in a piece of paper. So for this question, I just want you to tell me, do you feel like it makes more sense in the wide version or do you not? You don't have to, say, it's opinion. So no matter what you say, it won't be wrong. All right, so using your cursor, choose iron. How many protons in the nucleus? So iron. Well, if iron has an atomic number of 26, that means that it has 26 protons in the nucleus. Number 11, what are the symbols in order of the halogens? So we need the family halogens. Number 17, the family halogens. And that's this row right here, like I said, family 17. So we have fluorine, chlorine, bromine, iodine, and astatine. These down here are made in a lab. They're not really real. They don't last long enough for us to find out what their properties are, so that's why they're gray. They literally exist long enough to say we made them, and then they fall apart again because they're incredibly heavy and radioactive. So we're not going to include those as halogens. They're not really halogens because they don't exist long enough to be a halogen. We would assume that where they would fall, though. So you're going to write the symbols. So FClBrIat. And remember, in order. So to get the full point, you got to put them in order. So FClBrIat. Oh, I missed one. I bet a couple people did this themselves too. 650 degrees Celsius. I wonder if y'all caught that when I filmed it. I bet somebody did. And it's nice that it showed me that I had a blank one. All right, so what are the element symbols in order for the elements that are noble gases? So the noble gases are family 18. They're this group over here. This group over here, the noble gases, family 18. So we need the symbols in order. So helium, neon, argon, krypton, xenon, and radon. So helium, neon, argon, krypton, xenon, radon. Right now, let's see if it'll let us move on. Okay. By specifically selecting any of the properties at the top of the table, you can sort the table by individual details. Highlight the discovered option from the list. Can you find an element that was discovered in each of the following years? So we're going to look for the discovered. When was each of them found? And the year is going to be the best. The year slider is going to be the best way to do that. So to find that, you got to click on discovered down here. And you can see that iron was discovered in 2000 BCE, before Common Era. So that means 2,000 years before we started keeping track of stuff. So about 4,000 years ago. So what I want to do is figure out what was discovered in 1772. So if I type in 1771 in the year box, I'll see what things were discovered in 1771, and then I can bump it up to 1772 and see what shows up. Oh, did you see it? Wasn't there in 771, is there in 1772. That's right there, nitrogen. So, nitrogen was found in 1772. All right, how about 1807? So again, I'm going to put in 1806 so I can see what shows up when I go up to 1807. So 1806. Oh, did you see it? There's two that popped up over there on the left. Right, so these two over here, sodium and potassium, were both discovered in 1807. So K and Na were both discovered in 1807. All right, how about 1900? So we're going to go to 1899. Look how many things got discovered in that short of a time. Isn't that crazy? Science really made incredible leaps and bounds in the 1800s. It really did. Doctors started washing their hands. Anyway, that's a whole nother story. All right, so what pops up in 1900? Did you see it? Look over here on the right at the bottom of the noble gases. That's right. So radon was discovered in 1900. And then in 2000, what did we have show up in 2000? So we need to go to 1999. We got almost everything, right? So what did we get to show up? It's hard to see, but that little livermorium goes gray in between 1999 and 2000. Livermorium turns gray, and that means it was discovered. All right, that's that section. We're almost done. How many isotopes are listed for aluminum? So the isotopes band is up here at the top, just like the properties band. So we're going to click on the isotopes band, and that's going to tell us how many isotopes the thing has. So when you look at iron, for example, because that's the one we were on, it's going to show us all the different isotopes. So these are all things that have 26 protons, but then they have varying numbers of neutrons. And so that's where we get that atomic mass that's an average number that's a decimal, because you add all those up and then divide to get an average to find the mass of iron. Each of these are, as iron degrades over time. So I want to know aluminum. How many isotopes does aluminum have? So we're going to click on aluminum, and it says right there at the top, count 22, that there are 22 isotopes for aluminum. And you can see all of them there. And then how many isotopes for uranium? So we're going to find uranium down here, number 92. Look at all those lovely isotopes. And these are the ones, some of the ones, U-237 and U-235 are the ones that we like to use for fission. U-237 with that blue band around it is the most valued one. That's enriched uranium. Like when we find uranium in the ground, you can't use it directly like that. You got to do some stuff to it. You got to enrich it. Oh, there I am again. So that was, how many was it? Got to go back. 26. There are 26 isotopes of uranium. Moving right along, last page. All right, describe some of the shapes you see. The more you say, the more points you get, up to 5. All right, what I want you to do is click on the electrons tab up at the top and look at, as you go over, I mean, there was uranium. Isn't that wild? But as you go over each of these, there's a picture up here in the top right, and it'll show you what the electron configurations look like. When you find the homes for the puppies, what sort of patterns are they traveling in? And holy moly, do you see all this crazy shapes and things? Stuff is exploded out. Those two look like 2 balls of Play-Doh squished together. We've got some stuff that looks like pacifiers. We've got stuff that looks like a fidget spinner. So what I want you to do is describe in here, and the more detail you use, the more ones of those you describe, the more points you'll get. Describe in here some of those shapes that you see. Then you're going to hit submit, and you're all done. Have a lovely day. Bye.